Okay, today I'm going to do the second time of unpacking of CobaltStrike beacon. Because the first time I thought I have already unpacked it, but it is not successful. And now I download a copy of the shellcode from a live CobaltStrike team server, and then create a loader program. Um, to call it, the loader program will read the shellcode into a newly created buffer and then put the control, set up a flag to start up the shellcode at the very beginning byte and then let it run and then exit the loader program. So it is a multi-threaded program called loader to run both the CobaltStrike shellcode. The shellcode first will initialize itself and then unpack the other, decrypt the other um, code inside the buffer, and then finish once it load everything and create the PE file, and then it will keep running and then exit. One thread is exiting the the program from there on. So first of all, let me show you the program called loader, and then I point the loader program to the shellcode that I download from the team server. And here I create the Wireshark to capture the network activity, see when the shellcode have been fully decoded. So I want to stop at the location before the shellcode initialize itself to run it. So first of all, let me uh, put the control of the debugger back to the user code area. So I have to create, this is the previous buffer that I recorded, set a breakpoint right there. I have to put the virtual arrow as one of the breakpoint, and then and also let me run these loader program. Now I have the virtual arrow and then run until return. So I have a buffer created, nearly nothing right there. I copy this value and then go back to the user code from the kernel base DLL. Now I go back to the loader program. In the loader program, I hit Control G and copy the value right there. And I set a big point at the very beginning of the newly created buffer. Now I go back to the user code, load the program. Now I pay attention. Now load the program. We have only two threads. One is main, another is one. Now let me hit, go to move memory. Step one, the loader will read the shellcode into the newly created buffer. And then I hit create thread. So I hit this delete. Now the thread has been created. Let me go to check it. There's a new thread called number 2, create. So I put it in the highest priority and then change the main to the lower and one to the lower and lowest. Now I go back here and click step into it. So step into it to go to the reflexive loader. So I step into it and then now let me check the flag. The flag is in also in main. I need to click more function thread in main. Okay, the free may be the highest because the free is the newly created thread. I move to the free, move to tiles, two, go to the lowest. Now let me click again. I'm still inside the virtual arrow. What is the thread running? It's running free. So let me go to the return, hit until return. So I click return. Now I am in the first byte of the loader. I mean, first byte in the thread 7688, which is the thread number 3, 7688. So let me try to let it run until the appropriate location. So make sure I need to always monitor this and also this. So we see quite a lot of stuff right here. Let me set up the bar right here and go 6, 8, yeah, 7688. Now suddenly I change back to the kernel base, check the flag, go back to main. So let me suspend thread. Now see if I go back to free. Yeah, I'm go back to free and then set the breadcrumb right here. Okay, run. Still in free. Six, 7, 6, 8, 8. I don't see any green packet, so I'm still okay. Now 7, 6, 8, 8. 7, 6, 8, 8. Now I need to be careful. I don't know what is going to call. 7688 seems okay. Oh, let me go to the log, see what happened. It seems we call the DLL have been loaded, even though I don't have the DLL functioning in the shellcode. Now start over until return. Still in 7688. Now I go to the one of the locations that we need to take care of. This is one of the API hash. The hash is exit process. So I'm quite sure I should be able to do the unpacking right now because once I finish this, it will exit process. So let me go to checking the thread still number 3. And then what is the location of the memory? This should be BF something 40. BF 40. You can see it's private, executable and readable and writable. Let me dump this file and I will put it into my reversing package location. I call this loader 2. And then I create another version called loader 3. I will tell you later on why I need to do so, because I need to change something to make it looks like fully unpacked. Reversing 6 something. I need to create number 3. Okay, so before I go ahead, let me minimize it, minimize this, and I'm using another tool called um, File Insight to load this newly dumped file. Yes, this is 2 and 3. Let me open 2. You will see there is some other um, code or data in front of the MZ header. Can I find the MZ header? Let me pause a little bit. Okay, I found some error right here. I should dump this memory location to the 10 folder. CS reversing 6 8 something. Let me delete all other things first. Yes. Delete this. Delete this. Delete this. Okay, so I create one dump file to the 10 folder CS reversing 6 something. So I can have create 3. Okay, now before I go to anything, I minimize it and use File Insight to load the number 2. Load the number 2 is not looking good. Let me try again. Try load the number 3. Now I find 4D5A. Now let me try to delete this 4D5A. Delete all the byte, cut all the byte before 4D5A. Now save it. Then if I using this, try to open the file to verify it has been fully unpacked. The number 2 is not correct. Somehow I don't know, but number 3 should be okay. So I put it into the PE Studio. Now you see the shellcode now is fully be readable by the PE Studio, and the compiler time of this shellcode is in the 2022 in August 4. And you will see one of signature export called reflected loader right here. And then you will find some other material. And other than that, you can drag it also to the strip PE. And strip PE, you can fully identify this PE file. If I click the characteristic, you will find it is a DLL. So I'm comfortable. The 3 is okay. Then let me try to let it run, see whether I can let it run and find the connection right there. So let me step 1, 2, 3, and call EAX, and then run. Now you see I'm connecting to the C2 server by using this strange material. Now let me stop recording and disable the network connection. So I should be safe, not connecting to a live server. So I can keep a copy of the PCAP. I would like to using CAP instead of the next generation PCAP. Go to the C drive, 10 folder. CS. So I minimize it, and you will see it paused. If I keep on running, I can keep on running. Maybe I need to run until back to the user code. It's running. If I go to the I go to this link, see if I can see anything on here. Search for the user model string references. You see quite a lot of interesting module right here. And then, okay, so I assume I'm okay for this demonstration. But one last thing, I need to make sure to verify my shellcode is working. So if I go to the CS CobaltStrike scan, I'm supposed to be able to scan my file to identify the it is unpacked invalid. See if I can find the configuration. Okay, I have the configuration. You will see that it tried to connect to the C2 server. And then you will see that it tried to pretend connect to Google and something like that. So that is my example on how I do the unpacking of the live beacon.